Alright, so in this section we have logarithms. What are logarithms? They are inverses of exponential functions. So y equals log 2 base 2 of x is the inverse of y equals 2 to the x. So I started off by graphing our function from the previous section of y equals 2 to the x right here. So if you remember, if you plug in -1, your y is half. If you plug in 0, your y is 1. If you plug in 1, your y is 2. If you plug in 2, your y is 4. So the inverse of that, we flip the x and y values. So this is our table for our log function. Okay. So if I'm to graph this, at 1/2, my y is -1. At 1, my y is 0. At 2, my y is 1. And at 4, my y is 2. If I'm to connect these dots, there's the graph. And that is the graph of y equals log base 2 of x. And the reason why it's an inverse is because it reflects over the line y equals x. Alright, so we have a couple different types of logs. You have the common log, which basically means it's a log with a base of 10. It's usually written y equals log of x. So now you know when there's no base, it's 10. Okay, next up we have our natural log. The log is with the natural number e. So it's the log with a base of e, the number e. So we write it in two different ways. Log base e of x is the same thing as saying natural log ln of e. These two notations are exactly the same. It's going to be very important to remember that when we are actually rewriting these logs. All right, before calculators, the way that you can solve a log function without a calculator is we use the change of base rule, which is exactly what it says. You change the base to help you solve a problem. The change of base rule looks like this. If you have a function log base a of an x value ends up equaling, you rewrite it as log with a different base using the x value divided by the log of same base as up here, and you put the a value over here. And you always assume that a and b do not equal 1. So an example of this looks like this. Example, if you're asked to solve log base 16 of 32, you can solve this by saying log with a base of 232 divided by log 2 of 16 is the same thing as saying 2 to the what equals 32. So 2 to the 5th power equals 32, and 2 to the what equals 16, and that is the 4th. And you'll understand what I just did here in just a minute. Alright, before moving on, we have to learn the properties of logs. Again, this is review. So the way that you do this, first of all, you have to know that this will work for a being greater than 0 and a cannot equal 1. and any real number k. So when you have these three things intact, then you can say that log base A of 1 will always equal 0. Another property is log A, base A of A to K is always equal to K. And the last one is base A raised to log base A of K will equal K. And we'll do some examples of this in a little bit, and we'll come back to it to explain what this really means. And this all has to do with the fact that logs are inverses of exponential functions, and that's why these properties work. Now these properties are for rewriting purposes, so either compressing or expanding log functions. So the first one is called the product rule. Product rule basically means two things that are multiplied together. So if you have a log base b of two numbers m times n, you can expand that by saying that log base b of m plus log base b of n. So if you have multiplication, you split it up with a plus sign. Next up is quotient, which means division. So similar, if you have a log with a base b of m divided by n, you can split that up by saying log of the base b m minus log base b of n. So if you have division, you expand it using a minus sign. And then the power rule is basically when you have something raised to something else. So if you have a log base b of m raised to n, the way that you rewrite this is you take this power and you bring it down in front of the whole number to multiply it. So this ends up equaling n times log base b of m. Alright, so those are the main properties, and one thing that we talked about at the beginning, because logarithms are inverses of exponential, the most important thing for you guys to remember here is this little rule for rewriting logs to exponentials, and you'll see some examples in just a second. But this is very, very important. If you remember that log base b of y equals x, you can rewrite that. And the reason why we do that is because you can't solve a log without a calculator, but you can solve an exponential without a calculator. So what you do is you take the base, you start here, you raise it to the x, and that will always equal your y. So what I just said, you take the base, you raise it to the x, and that will equal your y. So if you can rewrite a log into exponential, it becomes easier to solve. And some problems you're going to be asked to take an exponential function and rewrite it as a log function. So same thing, it's always going to be log base b. So you start here, this is your base, of y equals your x, if you're going to go backwards. Alright, so keep that rule in mind, and I'll show you what that means in just a second with the first 6 problems that we'll do in this video. The rest we'll do in class. Alright, so this part right here says, for each statement, write an equivalent statement in it's supposed to say log form, okay, because it's already in exponential form, so you have to rewrite it in log form. So all you have to do is take the statement and rewrite it in a log. So here's your base. So it's log base 2 of 32 equals 5. And that's it. You're done. You've rewritten it in log form. Same thing here. Log base 2/3 of 27 over 8 equals -3. So here we have log base 1 over 100 of 10,000 equals -2. And here we have log base e of cube root of e equals 1/3. And remember what I said earlier, the way we rewrite, this is the natural log right here. So the way we rewrite this is we say ln cube root of e equals 1/3. This is the correct notation. So that's pretty straightforward. Now for the next two examples, we want to, for each statement, write an equivalent statement in exponential form. So now we are going to start with the log and we want to write the exponential. The key to remember is the base of a log is always going to be the base of your exponential form. So we start with our base, so 5 raised to 1 is equal to 5. Now it's easier to see that this is a true statement because it makes sense. 5 to the first power is equal to 5. So here we rewrite this as 3 raised to the 2/3 equals the cube root of 9. And if you can't tell that this is correct, you guys remember that saying 3 raised to the 2/3 is the same thing as saying the cube root of 3 squared is equal to the cube root of 9. And 3 squared is 9. And that is the same statement. But this is the answer we're looking for. This was just the check. All right, I'm going to stop here today. We'll do the rest of these together in class. But this was just the review part of it that I think you guys already should know.